So sorry about that. It's a network issue, but we can continue. Okay, I'm gonna continue. I had a network issue, and then I restarted the live. So this is how we count in organic chemistry. If there is one group, one branch with one carbon, then that is methyl or meth. If there's two carbons, it's eth, three carbons, it's prop, and so on and so on. So this is what we use for IUPAC naming. This is what guides us. So step number one in naming organic molecules is determining the longest chain. We call this the parent chain. So first you have to determine the longest chain. For now, I'm looking at single branches, no branches, no branches. I'm looking at compounds that do not have branches so that we can get a better understanding of how to name these compounds before we make it complicated by adding branches. Okay. So the first example that I have here is this. If I were asked to name this compound, the first one, I'm going to count the number of carbons. This is the longest chain because there are no branches. This is the longest chain. And I can see that there's two carbons. At this point, it doesn't matter which side I start counting from because I don't have any branches. Yes, that is okay. You can take down notes. Okay. So this first example only has two carbons. And remember, I said that if there's two carbons, then it is going to be eth. Now, notice that this is just an alkane. Here's another thing that you need to know. This is the homologous series. This is basically just different families, if I can put it like that have something in common about them. For example, all the Kumalo people have big foreheads. I'm making an example. So when you see a person who has a big forehead, you can, tell that, okay, this is probably a Kumalo, so that's what a homologous series is. It's where you have groups of compounds that have something in common with one another that makes them related. So alkanes are the ones that have single bonds. When we are naming alkanes, the name will end with ANE. And then we have alkenes. Alkenes have double bonds. When you're naming an alkene, the name must end with ENS. Alkynes have triple bonds and their name must end with -ine. I'm going to start with those three for now, just so that we can collect some wins and make sure that we are understanding. Okay. So this example, because it has two carbons and it is an alkane because it's only single bonds, then this is going to be ethane. Ethane, because there are two carbons. Let's look at this one, number 2. We have 1, 2, 3, 4 carbons in the parent chain. Let's go back to the numbering. 4 is bute. So since there's no double bonds, there's no triple bonds, there's no branches, it's just a straight chain, this is going to be butane because it is an alkane. And then number 3, notice how number 3 has a double bond. This is a double bond. So because there's a double bond, it means that the name is going to end with an "in" because it means that it is an alkene. Now there's only 2 carbons, 1, 2, and remember I said if it's 2, the parent name must have an eth. So this one is going to be ethene. Eth because there's 2 carbons, ene because it is an alkene. And the last example that I have, so I'm going to count the number of carbons. 1, 2, 3, 4. So if it's 4, it means that it is bute. But we have a double bond here. The double bond is on the second carbon. So this is going to be bute 2 because that's where the double bond is. Ene because it is an alkene. Now let's look at branches. Still looking at alkanes, alkenes, and alkynes, but now adding branches. A branch can be an alkyl group. We're adding branches. A branch can be an alkyl group. For example, can be a CH3 branch. Because there's only 1 carbon, this would be methyl. Methyl because it is an alkyl group. If we add a branch with 2 carbons, CH2, CH3, this is 2 carbons. This is going to be an ethyl group or an ethyl branch. Branches can also be halides. For example, fluorine, which will be named fluoro. It'll make sense when we're doing examples. bromine, which will be named bromo, iodine, which will be named ido, just to name a few. Now let's look at examples where we have branches and how to name when we have branches. This is ido. Okay, I'm going to draw a structure and then I'm going to give you an opportunity to name it and see how far you can go with the naming. We'll start with an easy one. It's very important to note that when we have added branches, there is another rule that must come in, that you must take into consideration as well. Now, when you are counting the number of carbons in the longest chain, you need to start counting from where you are going to reach the branch first. So the branch must have the lowest number attached to it. Yeah, that makes sense. So this one is right in the middle. So for this one, it doesn't matter which side you start from because it's literally right in the middle. So this name is going to be, first let's look at the number of carbons in the longest chain, which is 1, 2, 3, and we said 3 is prop. So I know that my name is going to be prop. And then also notice that these are all single bonds. So this is an alkane. So there's going to be propane. That's the parent chain. But on the second carbon, there is a methyl group. On the second carbon, there is a methyl group. So I'm going to put it 2. And then I have a methyl. So the name of this one is 2-methyl-propane. Let's look at another example, a more challenging one. Just gonna underline here. Please feel free to take this down. Yeah. Okay, now this is the last example that I want to look at today. It's quite loaded. But remember, the first step is to look for the longest chain, the parent chain. Okay. And remember, we said that you must start counting from the side that is going to give you the smallest number to the branches. So if I start counting from the left, if I say this is 1, let me use a different color. This is 2, 3, 4, 5. If I go this way, I'm going to go 6, 7. But that's not the longest chain. Let me show you the longest chain. If after 5, I go down 6, 7, 8. Now there's the longest chain. I hope this is clear. So the longest chain is 8, and 8 is octane. Now notice that there are no double bonds here, so I know that the parent chain is octane. Now I need to look at the branches. If you look at carbon number 2, there is a methyl group, this one, and then there is another methyl group over here. So on carbon number 2, we have 2 methyls. Where else do we have a branch? On carbon number 5, I have ethyl, which is this one over here. Let me use a highlighter. Something light. This one over here. This is an ethyl group because it's 2 carbons. So now let me put that in the name. So on carbon number 5, I have ethyl. And then on carbon number 2, I have 2 dimethyl. I will explain that just now. 2.2 dimethyl methyl octane. So when we have 2 branches on the same carbon, we put it like this, 2.2. So on carbon number 2, there's 2. That's what this is saying. On carbon number 2, there's 2 methyl, and di means 2. So if it was 3, it would be trimethyl. And octane, which is the longest parent chain. Hi, yes, I do have tutoring classes online and in person, depending on where you live. You can contact me on my number. It is on my profile picture. Thank you so much for coming through to my live lesson. I'll see you on the next one.